So yesterday in our course, mainly we discussed regarding on the potential areas that we can adapt renewables to oil and gas industry. Okay, so what we mentioned regarding on, for example, some EOR applications, some areas that we can adapt to produce, generate electricity by using renewables, by using heat. Okay, so now we will go into the details of the energy sources, these renewable energy sources, and we will see what type of work has been done till today and how it can be adapted for future applications also. Okay, so let me make it full screen now. Make it full screen. Okay. Let me open the pen as well. Okay, now also it can be seen, right? The screen can be seen, no problem.
Yes.
Very good.
Yes, sir, we can see.
Okay. Okay, so I will start with the outline firstly. Today, in the second day, we will mention about the role and the future potential of renewables in oil and gas industry, as I mentioned. So firstly, I will talk about an introduction regarding on this. And then we will start to examine one by one the energy types and their application areas in oil and gas industry. So solar energy will be included, wind energy will be included, geothermal energy, hydropower, as separate from the hydropower, Seaway energy, and in the last part I will mention about the nuclear energy. So, in last decade, the environmental damage and other harmful effects of fossil fuel extraction induced what an awareness of governments and oil companies. So most of us faced about this issue. So the direct effects of sulfur oxide, nitrogen oxide, and CO2 boost the developments to produce a clean petroleum product materials which keep the carbon footprint minimum and free of sulfur and oxygen. But besides the technologies that reduce the emissions of the sour gases were developed. So researchers also start to develop projects and ideas regarding on what the integrating the usage of the renewable resources and adapting them into the petroleum industry. Renewable energy production techniques by such as using wind turbines, Seaway turbines, solar cells, photovoltaic cells, and even geothermal waters have a strong ability to decrease these harmful effects of the fossil fuel and the greenhouse gas emissions which release to the atmosphere to minimum levels. So it will pave the way of producing hydrocarbons in a more clean and efficient way. So in the Paris Agreement era, we call this era as Paris Agreement era now. The renewable energy investment, which has gradually become the focus of the global energy investment, has started to enter a new stage of large-scale applications. So the new energy business has been preliminary competitive with the sharp decline of the cost now start to become to be feasible with less costs as well, right? So the rapid change in technology and living style of the human society will speed up the coming of the peak of the oil demand as well. Okay, but it is actually the mega trends for the oil companies to be positioned into an integrated energy provider. So therefore, super major take active measures to lower
Sorry, sir.
Yes, please.
We lose your screen.
Yes, can you please share again?
Okay, this happens a lot. Okay, we will share again. Now you can see it, right?
Not yet.
Yes, sir. Yes.
Yes,
we do.
Full screen, right?
Yes.
Okay. So we were talking about the super major take active measures to lower the carbon economy and avoid potential carbon risks. Okay, there are several researches regarding on this as well. So these research show that it is assumed to promote cleaning business strategy through selling oil sand assets and increasing the proportion of natural gas. Okay, so and also explore the new energy technologies and take a layout of new energy business through technology alliance with venture capitals. So, according to the BP statistics, the green energy production was over 10% of the primary energy consumption in the United States, Japan, Germany, Britain, and other countries. Actually, if nuclear and the hydropower excluded, the Finland's, for example, green energy consumption in the total energy consumption has led the world from 4.36% in 1990 to 9.33% in 1911. Okay, so with the average annual growth being 0.24% in the United States and Japan, the green energy consumption accounts for a high-level proportion of the total energy consumption and increased steadily and respectively increased from 0.73 and 0.64 in 1990 to 2.2% and 1.56% in 2011. Now it is double of that. Okay, now it is double of that, the 2011 result, which is consistent with the continuous efforts of promoting green energy. The green energy development in Germany, Britain, and France, and the other European Union countries, especially after entering the 21st century, has picked up the speed ratio and make it double all their levels compared with the 10 years ago, the levels of 10 years, all right, 10 years ago. So European countries are the fastest growing countries, we can say. So the energy efficiency of the renewables compared to fossil fuels, actually. So I have a figure in here shows the average annual net renewable capacity additions with years 2011, 2013, 2014 and 16, 2017 and 19, and also 2022, 22. All right. So global renewable energy capacity additions in 2020 beat the earlier estimates actually, and all previous records despite the economic slowdown that resulted from the COVID-19 pandemic. So according to the data released today by the International Renewable Energy Agency, ARENA, the world added more than 260 gigawatts of renewable energy capacity last year, exceeding the expansion in 2019 by close to 50%. So ARENA's annual in 2021 also shows that renewable energy's share of all new generating capacity rose considerably for the second year in a row. So more than 80% of all new electricity capacity added last year was renewable, with solar and wind accounting for 91% of new renewables. In country by country, if you examine this one, so we will get the same increment levels for the countries as well. So the renewable share of annual power capacity expansion, when we compare it from the 2001 through to 2020, so we can see the increase in renewable shares, and the increase in non-renewables also. So when we compare it in this graph, we can clearly see that there's a decrease in the non-renewable share and the increase in renewables directly. Renewable share also with the red line you can see. So let's make some explanation in this figure. So for example, as the technology progressed in recent years, the cost of the wind energy, solar energy, and power battery has decreased significantly. But solar photovoltaic modules average cost has decreased from almost $80 per watt in 1976, okay, to $0.41 per watt in 2016. Okay, so solar bidding tax price, for example, in India and Abu Dhabi, for example, was about 2.9 to 4.4 cents per kilowatt hour in 2016, which was less than the traditional fossil energy cost. So from the statistics of Wood Mackenzie, so a very famous one, Wood Mackenzie, the cost of the battery pack has shown from the $1,000 per kilowatt hour in 2010 to $227 per 4 kilowatt hours in 2016. So when the battery costs fall below the $100 per kilowatt hour, pure electric vehicles will establish the absolute advantage on fuel cars. Okay. So now let's go into some more into details one by one, starting from the solar energy with the principles of solar energy. So in this figure, you can clearly see the working mechanism of a typical photovoltaic. PV, photovoltaic means solar cell, right? The solar energy is described as the radiant light and heat that's sourced from the sun and can be provided for the use of mankind by using many ever-evolving technologies such as solar heating, photovoltaics, as you can see in the picture, solar thermal energy, and artificial photosynthesis. So here in a photovoltaic system, it typically includes various numbers of solar panels, and each of that formed from many solar cells, little solar cells, photovoltaic cells. So a solar cell is the main mechanism that uses the energy of light and generates electricity through a conversion process consists of some physical and also chemical processes. So it named as the photovoltaic effect. Okay, so the cell mainly includes two types of semiconductor materials, such as we call it N-type and P-type. Okay, and the small current for each small cells, the current that generated between these N and P-type. Okay, a circuit, small circuits, and the generation of all small cells generates an electricity mainly in a photovoltaic cell. All right, so there are some types of these photovoltaic cells. So mainly, for example, here in the industry, in the market, there are 4 different types. Actually 3 different types, but we can consider as 4. One of them, crystalline materials. This is the first one, actually, cheapest one, actually. Not cheapest one, sorry, this is a little bit expensive. Crystalline ones. The second one is cheap. So this uses the silicon, most widely used material, as most widely used material. As I mentioned, this is expensive materials. The highest efficiency that can be reached is 20% in the laboratory, not in the field scale. Field scale, these efficiencies goes nearly 12, average 12 to 15%. Okay, 15% also a good efficiency in the field side. So another one, second one, amorphous thin film materials. So these are cheaper compared with the crystalline ones. The efficiency is around 7 to 10%. Okay, so it includes silicon, gallium arsenide, copper, indium selenium, and titanium dioxide, which one of the famous ones is the titanium dioxide. In here are the main materials. Another version of this one is the dye-synthesized solar cells. These ones also in the exploration phase still. It can be produced with a very low cost. However, the maximum efficiency is around 10% currently. There are some research centers in Turkey. Also, there are some research centers. One of them I am involved as well here in Izmir. So they are trying to produce, synthesize new materials by using new materials. They are trying to increase the efficiency of these dye-synthesized solar cells. So the third generation solar cells are divided into 2 different groups. One of them is organic polymers. These are candidates to provide the best solution, however, still in the development phase. There are some studies, for example, one of them, Zhao et al. Has investigated this one, and their efficiency maximum reached to 13.1% by using a neopolymer donor in 2017. So still, I think the highest one. So having a lightweight, being flexible, promising lowest cost, being more environmentally friendly by including less toxic materials than inorganic materials. So these can be chosen one if the efficiency can be increased more with the future development technologies. Another one is the quantum dot solar cells. These are also in the development phase and produced by using the nanotechnological developments. The efficiency is around 30% in the laboratory measurements. In a clean room, these measurements has been taken. But when it comes to the field scale, so this efficiency is lowering. We will discuss about the reasons of that. So in theory, as per the calculations of Luc and Marty Deyer's research, it's possible to reach 63% maximum efficiency by using these quantum dot solar cells. Not reached in empirically not reached, but theoretically it's possible. Okay, so we said that we said I would like to mention actually a little bit about the types of these ones. So here in the left figure, you are seeing that there is a P-type mono 5 busbar cell and the N-type 12 multi-busbar cell, two different versions of the solar cells you can see here. And also with different materials used, the solar cell types and their efficiencies has been given in the right part. For example, here you can see polyperc, the synthesized material set at 16 to 17% efficiency, monoperc 17 to 19%, and the maximum efficiency that we can get from the N-type IBC they called, and the maximum 23% efficiency could be get. All right. Actually, solar panel efficiency is defined as the ratio of generated electricity to the total amount of solar energy fall on the panel surface. Okay, so solar energy technology has been improved tremendously in the recent 5 years. The world's average panel efficiency jumped from 15% to 20%. In the previous ones, the earliest ones, 5% to 8%. It was when this solar energy area just in the beginnings when it started with the 5%, 8% efficiencies, right? So there's a development, it's still going. So for example, if you reach the panel efficiency from 15% to 20%, what it means? It means that the power output of a standard size panel increases from 250 watts to 340 watts, right? So this is a good jump actually. So the technological developments are still ongoing. Hope that it will be much more efficient cells will be developed. So the cell configuration and the cell material are the most important factors impacting the photovoltaic cell efficiency, as I mentioned. So the widely used silicon materials are P-type and N-type, already mentioned in the figures. The numbers of the bus bars and the passivation type is also very significant for this efficiency, and their design, how you put the dots, also very important. Another factors are cell temperature, cell type, irradiance level, and the interconnection of the cells, also crucial parameters which influence the overall panel efficiency. So the color of the panels is also important. For example, black color absorbs more heat, and more heat causes the higher resistance in a cell, so which in return reduces the conversion efficiency. So These are the types also. Now I would like to talk about the companies who are doing these jobs currently in the market. As you can see, SunPower, with the efficiencies I put also, SunPower, LG is available, Hyundai, one of the very, very famous ones, Rex Solar as well, Canadian Solar. So the efficiencies, when we compare, these are the ones which have the highest efficiency actually currently in the market. Okay, there are lower ones as well. So maximum power output also can be seen in here. I can see here the up to 400 watts with SunPower. So these are just to give you an idea about the market and the information. Okay, so let's go with the principles. Okay, these are the solar energy usage, but how we can adapt this to oil and gas industry, what has been done till today. So solar energy is used in oil and gas industry for two reasons. One of them to generate electricity, and especially in the remote areas like offshores and deserts, whatever. And in the second one, the steam generation for ER operations, using as a heat source in the steam generation for ER operations. So oil and gas fields are mostly located in areas where logistically difficult, such as iced Arctic area zones and deserts, offshores, as I mentioned, to reach over and supply water and electricity continuously. So a conventional method for electric supply is to use diesel generators, most of them. So the latest development of new technology materials paved the way of building up more economical and environmental friendly renewable solutions that aim to reduce the environmental footprint. So using photovoltaics or any hybrid systems that assist the conventional methods with the photovoltaics or wind turbines, we will discuss, caught the attention of the industry for the aim of lowering the carbon footprint and greenhouse gas emissions. Okay, so one of the works in here regarding on this solar energy usage in oil and gas industry, Kuwait Oil Company, KOC, has done a smart project actually regarding on this. They used the solar system at the selected well site area of the Burgan field to supply power to a terminal unit as well as wellhead instruments in 2017, and they successfully done that one. Actually, in the light of this project, there's a paper, Halabi et al., which described the way of using the solar panels, supply processes, heat generation for low and medium temperature processes, such as dewatering, desalting, and degassing. So I really suggest you to read this paper. Gives all the details regarding how they successfully implemented the solar energy, solar sources to a field, a smart field actually. Another work is Dachaba et al. They proposed an ESP-based wellhead system for remote wellhead operations of marginal oil fields that has the power supplied by solar panels. Also, this is a success, also reached to success, this project as well. The system eliminates the need for a hybrid system that will increase the cost by using a charge controller and the battery bank. So lower the electricity cost actually. So additionally, an inverter system that provides a conversion of the electricity produced by solar panels as well as the energy in the battery bank to AC is used. So some different applications also, sub-applications also can be used to lower the costs by using the renewables as well. Another one, as I mentioned, the heat. The steam generation for ER processes. As we already know, all of us, mirrors affect the sunlight on a pressurized, this works actually, this uses the mirrors that reflect the sunlight on a pressurized water flowing pipe and lets the water flow in a steam temperature. Okay, so this is a beneficial system, but also not only beneficial system, it's advantageous to use as hybrid mechanisms as well. For example, in first case, you can make it with fuel fired. You can reach it to a certain level of heat, and then you can maintain this heat. You can use it to maintain or increase the level of your heat in the levels that you mentioned, all right, that you required. So with this method, there is a project which shows that your heat, the temperature when it is passing from the mirror zone, at the end of the mirror zone, it can reach up to 1000 centigrade degree. So very high heat can be produced with this method actually. Okay, so actually, as I mentioned, with a fuel-fired system, due to the daily cyclic fluctuations in the steam injection rate by depending on the day and night, sunlight effects, seasonal effects, and environmental effects. What are these environmental effects? Dust, soiling, and sunstorms. Sunstorms, we have to be careful, and you have to get your precautions according to these. Okay. If you get your precautions on the time, and if you use it in a hybrid system, so you will not affected from these variations and effects. So when the same amount of cumulative steam injected, for example, compared with the concentrated steam injection in the same time period, daily cycles of solar system injection do not have any negative effects on the recovery. This is proven and showed in some projects as well. However, the steam injection rate fluctuations can be harmful on reservoir structure in long time period. Why? Due to its daily heating cooling effects, as well as the seasonal variations on reservoir rock, which change the reservoir stress and negatively affects the vertical displacement. So in terms of reservoir, we have to be careful and avoid having extra fluctuations in the heat levels. So because of that, I have to maintain my heat. So hybrid system for now are the best options to use this method. Okay. So advantages and disadvantages. Actually, in recent years, thanks to both renewable energy transformation and the government incentives in many countries, great progress has been made in the use of solar energy systems, especially in last decade. So a way of using solar energy is the conversion of sunlight into the electricity using direct photovoltaic panels or indirectly concentrated solar energy. Solar energy can be considered as the oldest and main source of energy discovered actually. So solar radiation contains impressive amounts of heat that reach the Earth's atmosphere and facilitate most life processes on the planet. It's a renewable energy source that can be used directly for lighting and heating without being converted into electrical energy. Depending on the geographical location, efficiency in the use of solar energy increases according to the angle of exposure to the sun's rays and the duration of the exposure. So although the solar energy has been used passively since the past, it's actively used for the production and heating of solar energy, especially with the development of materials used in absorbing solar energy. So active systems are more cost-effective but more efficient systems than the passive systems. Active systems are used first in heating systems and then in electrical energy production systems with technological developments. Okay, and for example, there is a work Sadi et al. According to the Sadi et al., the solar energy can be converted into thermal energy for heating in homes, buildings, and greenhouses, and directly generates electricity when using heat from solar connectors to heat steam generating fluid used for generating solar power plants. So in today's technology, some projects which are trying to adapt this solar energy usage to smart cities, and the city, it aimed that this smart city has to be enough to produce its own energy itself. Okay, So, of course, this has a very long-term project, but there are some applications. One of them in China, one of them in Spain, as I know, and in United Arab Emirates started one of them. Okay, so there are some smart city projects, and solar energy usage will be one of the main methodologies which they use to generate their energies. Some of them include the usage of the hybrid systems by using natural gas and solar energy, natural gas and wind and solar. Okay, so some hybrid systems will be used to avoid the seasonal change. It has to be used. Okay, so here the main aim is to lower the carbon footprint and the emissions. All right, so how much we can lower this one, we will succeed to control in the end we are reaching to the global warming issue. How much we can succeed to lower it, we will succeed to pave the way of avoiding from the global warming issue as well. So advantage and disadvantage I was talking. So one of them is the diversification of the energy supply, the elimination of toxic gases, sulfur dioxide, toxic particulates, and greenhouse emissions, as I mentioned, amendment of the degraded lands, water resource quality improvement, decreases in the dependence of fossil fuels and increase national or regional energy independence, supplement of electric in rural areas, usage of solar energy for generating electricity and thermal heating for ER processes, no grid connection problems actually. What are the disadvantages? Two main disadvantages we can say. One of them, it requires an extremely precise mirror control and robust reaction to process change need. And the mirror position change could result in solar energy input reductions, and the system could be out of control easily. So because of that, we have to maintain the operation in a very efficient way if we use these mirror solar panels to heat. So you have to be very careful in each step of your workflow operation-wise. Okay, so let me continue from this point. As another slide, distributed solar PV capacity growth by country and region. So by years, as you can see here, starting from 2007 through to there are some forecasts in here up to 2024. So as we can see, according to the countries, there is a very huge increase by time. Especially in China, we are seeing this one. North America compared with the 2007, they have as well. Europe had some fluctuations, but still on the way. Asia Pacific, Latin America, and the Middle East countries, and the rest also can be seen in the figure. So here, this figure has been taken from the International Energy Agency report. Their Renewables 2019 outlook, actually, which includes the market analysis and forecasts, included between 2019 to 2024 as well on renewable energy and technologies. So the outlook set the solar PV capacity to expand by 50% in the next 5 years. The amount of this increase, actually 1,200 gigawatt, is equivalent to an installed capacity as of today. So distributed solar photovoltaics in homes is the next significant challenge for the electricity providers and policymakers, of course. So I am coming, by this information, I am coming to what? To smart cities. So developing the smart city concepts all over the world will make a jump, will give a jump to this solar energy usage, definitely. So the ability of consumers to generate their electricity may rise very rapidly. According to actually the International Energy Agency, the distributed solar photovoltaic will increase 320 gigawatt, accounting for half of the total crowd. Okay, so let me discuss a little bit about small calculations, easy calculations. There is one factor, actually solar radiation distribution you can see worldwide in the figure, solar resource map. So here there's a factor called direct normal incident, DNI, solar radiation, which is averagely assessed per year for a related project area and the function of radiation being received directly from the sun. So here in QT, as you can see, the annual energy output from any solar facility, kilowatt hour, sorry. The DNIT, total annual direct beam sunshine received at the location. The total array of collectors, average efficiency of the collectors as dimensionless has been given in the formula as well. All right. So these are the information that I can give regarding on the radiation and an integration of fuel-based steam systems with solar-based steam systems based on day-night cycles. As we mentioned, there are some changes, variations, seasonal change, day-night shift, day-night cycles. So we have to compete with all of these when you are in a project which based on solar energy usage. So actually concentrating on here one of them, there is a technique called solar power, concentrating solar power, CSP. So this need to be used in a very efficient way. So I will not give the details of this one because it's a very detailed one. And the steam by oil field once through steam generators or simply fuel field steams. Actually, another one, the effects of solar-based steam injection on sandstone and fractured carbon formations has to be investigated. So day-night cycles for steam injection rate do not actually, these cycles do not affect that much the oil rate produced and the final recovery. So the mass-based steam injection per day has the same effect on the parameters stated above, even if the daylight duration is around 8 hours or 24 hours. Okay. So the usage of solar energy can be fully capable of the steam generation for EOR steam instead of fuel-based steam generation. Okay. So let's go some more into the details about equipment durability. For example, herein we can talk about the Middle East, one of the toughest locations in terms of heating and the situations, operational situations. So seasonal change, the cycles day and night, and the weather and or harsh desert conditions are one of the parameters which affects the equipment durability directly. What type of? It can be resulted in bending of the mirror and torsion of the mirror. Okay, so there can be some problems can be faced. Applying the conventional CSP techniques such as parabolic through, linear Fresnel, and tower to Kuwait. There is a project in Kuwait regarding on this, and design an optimal configuration is a challenging situation owing to the harsh nature conditions. This has been taken from Halabi's work actually directly. Okay. So relying on some model results that they generated, the enclosed through design developed exclusively for Kuwait's harsh, what you mean by harsh, windy and dusty formation, desert conditions, gave satisfactorily pretty results not only for Kuwait but also for Oman and California. They compared their work with other works that has been done in Oman and California, and results are quite good compared with the other ones as well. So based on the application in United Arab Emirates, there's another application. It has been observed that the parabolic through system is influenced by the accumulations of dust and wind. By inferring, this technology needs to be further improved for these conditions. In presence of harsh conditions, it can be thought that the enclosed through system is currently the best solar technology for the oil fields in the Middle East. So, operation-wise, there is a continuous monitoring needed for the mirrors to avoid to get any problem sourced by these harsh conditions like dusts, winds, which will directly or indirectly affect the transformation of heat through to the pipes actually. Okay. So the same thing is also valid not only for mirrors, for the solar PV panels as well. So the cleaning issue from the dust, for example, is very crucial, especially in desert areas. Close monitoring and close precautions is definitely needed. So in terms of economical aspects, we can say that, for example, in the Middle East, one of the locations that has the harsh conditions, okay, the gas-based steam generation systems have begun to be replaced by the solar system generation systems actually, which are more feasible and cost-effective methods. So future projections about solar system generation for thermal EOR, as we mentioned, mirror method, for example, these show that the expenses, including both operational and maintenance, are predicted to be tolerably lower than the capital ones for the installation of the required solar panels and their equipment containing the significant expenses. So operational costs much higher for a gas-based steam generator because the purchase costs of the natural gas are substantial. For instance, there's a study in 2011, Molchanov et al. They showed that the amount of natural gas over 280 billion cubic feet per year was consumed only in California, US, for thermal EOR purpose, which is obviously emphasizing the importance of the solar energy use in thermal EOR applications, such as natural gas consumption correspond to approximately 1.3% of all US gas consumption. Okay, so there are some other works as well, but I would like to stop in here with this one. I would like to give some more examples related to the oil field projects actually. So here we can see there is a pilot plant has been built in Oman called Amal West in 2013. PDO deployed this one as the first thermal EOR pilot project in Middle East region, and solar system generation plant of 7 megawatt capacity was successfully projected at the Amal West field. Another one in Oman, Mira, due to the satisfactory results that has been taken in the upper project, this Amal West project, PDO Oman initiated another construction in 2017 in Mira, a solar EOR facility which will be more than 100 times bigger than the pilot plant that has been built previously. And the new development will consist of 63 greenhouse buildings with a total capacity of 1 gigawatt to provide 6,000 tons of steam per day when completed. Okay, so another projects and some solar EOR projects can be seen in here. One of them is actually 2 of them is from California, apart from the Amal West. So the capacities of these ones, for example, the first one 300 kilowatts, it's a low one, but the second one, which has been commissioned in 2011 and now it's in process, is around 30 megawatts, 29 megawatts. It's a very big project actually, so successfully now applied. So another example I would like to give, actually Kuwait in here is a very unique location for this one of the hottest places in Earth. So it's a good candidate to benefit from solar EOR actually. So more than 12 billion barrels of heavy oil are estimated in the lower parts of North Kuwait. Okay, so these heavy oils will need in the future also. These heavy oils will need some EOR projects, of course. So these thermal EOR projects, if thermal EOR projects are applied, so the usage of the renewable energies, solar energy especially, will be very crucial and will be very beneficiary for in terms of project-wise, in terms of worldwide development of these renewable energies. So thermal EOR has been favorably tested already in the carbonate formations at the Wafra field, and Chevron is targeting for a first phase production of 80,000 barrel oil per day. So Kuwait currently has a deficit of gas that's forcing them to import LNG, and the requirements of those thermal EOR projects would add more pressure to increase the gap. Another thing is that everything indicates that we will witness the massive projects of solar EOR recovery in Kuwait in upcoming years. Seems that. Okay. So I will continue with the Kuwait also. There are some major oil and gas fields like Burgan field of Kuwait, which uses the solar power for electricity generation. Again, I am coming to Halabi's work, Halabi et al. They give the way of solar panel usage for degassing, desalting, and dewatering processes. So solar power herein mainly used to supply electricity to a selected terminal unit, which distributes the electricity to a selected field zone. Okay. And other works, other studies also gave as reference to Halabi's work regarding on this one. They were in the head of this project, successfully implemented to this smart field system, the renewable energy. In another project I already mentioned, Hydropower's work. Okay, so they also used renewable energy in ESP pumps. As you know, the cost of an ESP pump is one of the highest ones in well structure, right? So in completion. So to lower as much as we can do the cost of this part will be also beneficial. So Idecheba has done a work related to this one and used solar energy to generate electricity for the usage of ESP pumps. Okay. Another one, the solar systems also started to use as heat source for thermal evaporation processes such as steam generation, humidification, dehumidification. Okay, this type of processes. It's a good candidate, to use actually. It's described as the condensation procedure that separates the pure water and condensate wastewater of produced water phase. It uses a water purification unit that produces water heated by the solar thermal energy flows inside the chamber. Okay. Here in the chamber, as you can see in the picture, here in the chamber includes a filler material to extend it to condensation time. An air blower is used to provide the ambient air that blows into the chamber in upside direction. Currently, I cannot show it with my laser pen in here because it's directly closing the screen, so I could not show it, but I'm trying to explain. So an air blower is used to provide an ambient air that blows into the chamber in upside direction. Okay, so following the condensation and separation processes, pure water and wastewater sent to the tanks directly. Okay, so in your operations, for example, the crucial parameters is to inject steam phase into the formation to increase the reservoir productivity, right? So in conventional systems, the burning fuels are used as the heat source to generate the steam by using water phase. However, companies are looking for some alternate sources now due to the high cost of hydrocarbon fuels and their harmful environmental effects as well. So there is a work in 2018. Velarde and Alejandro has done this work. They used a technique to heat the fluid by using the solar energy in oil and gas fields. And in this new methodology, the solar panels are mainly used to heat the produced water by using solar thermal energy. An isolated glass house is used to cover all mirror systems to avoid any dust or any dirt. All right, any outside effect, actually preserving from any outside effect. They use the glass house. So solar panels have parabolic shaped mirrors in this project, and the used ones include a reflective coating for a better reflection and heat transfer of what solar thermal energy. Okay, so here also you can see the effect of the shape of the mirrors that has been used. The pipe is passing through in the middle, in the center of the mirror shape. All right, so this is the CSPT, concentrated solar parabolic through technology system. Okay. Another work from Palmer and O'Donnell has been given in here. Okay, so here, challenge and lessons learned. Since its first deployment in McKittrick, California in 2011. So, one of them, harsh environments for delicate equipment. Dirt, wind, rain, enclosed through glass house needed, okay, to provide. Precise control in the construction. Proper QA/QC mechanisms need to be done in certain periods. Continuous monitoring is totally needed. Precise sun tracking, continuous monitoring. Compatible with existing steam injection facilities. It has to be scalable and functionable system. And specialized construction teams also needed to be put in the heads of these projects, definitely needed. Let's talk a little bit about the key points about the solar energy. For example, an increasing interest among the governments and companies to invest and develop alternative energy sources for energy security reasons. Okay. These alternative energies will still have a low rentability if compared with the traditional fossil energy. For example, we can say also that one of the main challenges of the alternative energies is related with the conversion of energy, which can be expensive and inefficient and typically requires changed infrastructure and facilities for the manufacture and delivering for the end users. Okay, so the technological innovations required to substitute the energy market still seems to be in the long run expecting to have a strongest presence after the year 2030. Okay. Within the oil and gas industry, the technology progress should be support the upstream operations in four different ways. One of them, improve exploration and new hydrocarbon resources, improve oil recovery, the IOR, from existing field, including no conventional resources, by the way, minimizing the environmental footprint, and the integration of multidisciplinary human resources. So, for example, companies such as Total, France, report their investments in renewables, especially in solar and bioenergy technologies, as way to fulfill the goal of the company of leading what the power market activities and diversity their portfolio in the global energy market. The Equinor, for example, Norway, describes its investment in renewable energy as a transition into a mixed energy provider such as wind and solar energy. Okay. Also, natural gas is typically used in the generation of steam for thermal EOR recovery methods. Right. The potential risks on natural gas supply and carbon dioxide regulations are driven operators in Middle East to look for alternatives to generate clean energy for green EOR projects in heavy oil fields in the region. One of the examples that I gave already, the PDO, Petroleum Development Oman, has implemented a solar steam generation power facility concentrating solar power on one of its heavy oil fields with a very promising results as the goal of the project were exceeded by 2%, generating 14,000 tons of steam in the first year of operation. According to this has been taken from Palmer and O'Donnell, by the way, with a low operation cost after the initial capital expenditure. So, for the success of the use of solar energy as alternative energy source in oil fields, it is required to have a potential of solar energy on site, as is the case with the Oman oil fields. So Oman has done this one in a very successful way. So the procedures, the workflow, and everything has to be followed and developed according to and adapted to another regions, right? Okay, so in CSP technology, mirrors actually reflects and concentrated the sun light onto the receivers, in which the solar energy is collected and then converted to thermal energy, which is used to generate the steam. So this technology can be produced the same amount of steam as gas with the same quality. So the operative costs of this CSP and EOR, for EOR actually, compete with the one of traditional generation of steam using gas, reducing the risks of market gas prices variations in the operation expenses. Okay. So, let me continue. These are the ones that I can say with the solar energy. Now I will pass to the second one, the wind energy. So, okay, let's start with the wind energy now. The wind is considered as one of the cleanest renewable resources in the world, actually. Okay. Actually, looking at the global level, the usage of the wind power is growing exponentially as well in last decade, especially. Many countries try to meet their certain amount of domestic energy demand by the usage of wind energy, most of them succeeded this one, and it shows an exponential increase, as I mentioned. Actually, historically, what we can say, the wind energy was used to lift the water by converting wind energy into mechanical energy using windmills, the conventional one, remember. So the wind turbines convert wind-based kinetic energy into mechanical one and the electrical energy. So the important parts of a wind turbine, as you can see in the left figure, okay, is you can say in a foundation part, in the lowest part, the grid connection, a tower, a rotor blade, and inside this rotor one, you can see the rotor shaft and nacelle, generator, electrical and control systems also included. A standard wind energy turbine include this one. So the blades are designed in here. The blades are designed based on the aerodynamic principles, like a height lift to drag ratio, all right, and these type of principles. So theoretically, the number of blades is determined considering component costs, aerodynamic efficiency, and the system reliability. An infinite number of blades with zero width is the most efficient design. However, it would be problematic from the point of cost, reliability, performance, and manufacturing. So a horizontal axis type with 3 blades turbine is the most widely used wind turbine type, because in terms of efficiency and other parameters, it's a kind of optimization, of course. this gives the best results. Okay. So the other important wind turbine components are, as I mentioned, in the can be found in the rotor part and the control system as well. This is very crucial parts. Okay. So what about the market? Before the market, I would like to say that the wind energy actually has a good potential of becoming number one among the renewable energy resources for the next generations. It's considered a clean and emission-free power generation method, definitely. So, Global Wind Energy Council reported that the total capacity for wind energy globally is now over 651 gigawatt. This is the 2019 result, by the way, and has a 10% growth rate was observed compared with the 2018. Okay. I did not actually get the results of 2021 because of these, some COVID-19 issues, these health issues also infected and it affected these results as well. So I did not get these results because of that. So the Global Wind Energy Council outlook highlighted a positive market outlook for the global wind industry over the next 5 years. It's estimated that the 355 gigawatt of the new capacity will be installed between 2020 and 2024, representing 71 gigawatt of new installations for each year. So actually the first year could not be satisfied, but it's expected, okay, in total. So here we can say that according to this top markets figure, we can say that China in terms of new installations in onshore and offshore, China has the most part of the market with the 44% in new installations in onshore and 39% I think with the offshore installations, new installations. But when we compare the total installations for offshore, of course, United Kingdom in the Gulf Coast region, they have 33% share. It's a very good result. And China in onshore is the first one with 37%. That's what we can say. Okay, herein, in terms of costs, I would like to give some information. For example, when you are installing a wind turbine, 8% of your total cost is going to the civil works. Okay, 12% is going to electrical works, and 75% is going to turbine costs. Okay, and 5% other costs, we can say miscellaneous costs. Okay, so this information also can be useful. So I put that one. So let's talk about the advantage and the disadvantage of the wind energy. The advantages of wind energy, first of all, it's a clean, fossil-free, and environmental friendly method to generate electricity. Wind turbines occupy less space comparing to an average power station of other resources. It's a very good advantage. The operating costs are low and it's a free energy. You can find the wind in most of the places in Earth, right? So in remote locations, wind energy is the most convenient energy generation method. And this is one of the crucial things. That's why we have to adapt this wind energy to oil and gas industry, especially in long distance remote areas like offshores, like deserts. We have to adapt this one. The extraction of wind energy is now more efficient owing to modern technologies. Okay. What about the disadvantage? The first case is varying and the wind speed is unreliable. So day by day, hour by hour, it can be changed, right? So it's crucial. It's crucial to make it in a hybrid, to install a hybrid system, establish a hybrid system. It's very important. Why? Because wind energy cannot replace fossil fuels, because large wind farms are needed for large amounts of power, right? Okay. So it is suitable for only low energy demands. Large wind turbines can be too costly and harmful for wildlife during the initial commissioning process. Wind turbines installed near the densely populated area may create some noise pollution for people living around. And also, it can be harmful in some situations to birds as well, animal life. These are also the topics that nowadays people discussing. Environmental, but what kind of environmental? The levels need to be described well. What about the potential? So wind power of the countries can be given in here according to the new installed capacity in megawatts. Okay, so as you can see, China has the lead, as we can see in most of the markets. So China and United States follows China, United Kingdom, India, and Germany, first 5 in here. Okay, so actually, looking at the general analysis in here, in the bar chart, it can be observed that the European countries' economy is much more dependent on the wind energy compared to the other countries, as they have high level of wind energy capacity installation compared. So on the other hand, China, of course, started to grow its wind power capacity considerably after mid of 2000s. And the driving force that China manifested in the market make this country the leader in energy industry. So they have a motivation regarding on that, and the result shows their motivation actually is really working. All right. So another one regarding on the investments actually, about the major oil companies, what the major oil companies making now in this situation, what type of actions they are getting. Okay, so the figure indicates the investment of major oil companies in renewables. Actually. So as can be observed from the bar charts, the Equinor, Norway, takes the first place in this process. And according to the statistical analysis, the oil companies will invest roughly, we can say, $17.5 billion in the wind and solar projects for the following 5 years. So more than 57% of this investment will belong to the Norwegian big oil company Equinor. Based on the analysis, it's predicted that this company will spend more than $6.5 billion in order to construct different offshore wind energy systems till when? Up to 2023. So the fluctuations in petroleum price will not influence this tendency actually a lot, as company has already agreed to launch the biggest Dogger Bank wind project. Okay, according to the offshore source in 2020. So BP is known as the first oil company, invested huge amount of money in renewable projects, in particular wind and solar energy, since when? Since 1980s. Okay, so by considering the chart above, as you can see here in the figure, the BP demonstrates the great interest in renewables. So looking at the late 2018 and the early 2019, BP restructured the 3 wind energy systems in Ware, Houston, for the purpose of optimization of wind portfolio actually. So BP bought 3 huge wind systems with the capacity of one of them 2025 megawatt, the other one 145 megawatt, I think. And 60 megawatt for growing wind energy facilities in US and increasing the business benefits in this field actually. So company actually continue to reinforce 11 wind energy farms situated in different states of USA as well. So which have wind capacities of more than 1000 megawatts in total. Another company, Shell, Shell invests huge amount of money again in order to grow the wind power. They are involved in both offshore and onshore projects like Equinor. Mainly offshore projects are developing. Actually, they have some wind farms, which is joint venture projects implemented between two different companies, of them Nuon and Shell. All right, Shell with Nuon. This is the first wind farm built in North Sea, the Egmont NZ wind farm. All right, and it utilizes 36 turbines in order to produce energy which will meet the electricity demand of more than 100,000 families. A very huge project. Okay. So another one, the last one I will give, the Total, the French company, invests in wind energy as well, increasing the usage of renewables. The electricity generated by onshore wind farms is implemented by Total Quadran company, which carries out the different projects with the capacity of 1,000 megawatt again. So it's anticipated that this number will increase by additional 250 megawatts. They are expecting to get to this level in 2025. Okay, let's go to the technological advancements. For example, in this figure, there are two different projects which has been developed. One of them shows a working principle of a multiple drone system in the left one, using the wind energy by using drones, actually. So the right one, the strategy to take off and landing, to create wind, to use the wind power as well. Okay. So there are some different technologies people currently actually discussing their potential and efficiency as well. I think in close future we will see some more new projects regarding on these, and they can be adapted to oil and gas industry also as well. Herein, actually, another one I would like to mention, the floating hybrid energy platforms. Actually, it's very crucial to increase the efficiency of energy produced from offshore, as it can contribute to a decline in the environmental factors and maintaining the costs down. So looking at the world, Atlantic region, for example, need this optimization a lot, because these areas exposed to the wind considerably, and their dependence on the wind energy demand will increase in future. The application of hybrid energy systems, which creates certain synergy between different energy systems, will be definitely specifically beneficial and effective in this context. So one of the best examples to this type of synergy can be given as the Blackbird system. So the Blackbird system generates the synergy among the wave energy converter, storage base anchored and an axial hybrid station, generator, and the mooring line. So there are more than 100 hybrid systems in European experts. Check 3 of these. They call Spartors and combination. Okay. Some technical ones, I will not go into details. The main difference actually between the conventional floating wind turbines and this method, the hybrid method, an additional component called the wave energy converter joining to the hybrid system. So it makes the electricity generation much more active, and lowers directly the change, the seasonal change, the effect of the seasonal change and variations. So, renewable energy production, what about the wind power usage in oil industry? Renewable energy production techniques such as using wind turbines, sea wave turbines, solar cells, and even geothermal waters have a strong ability actually to decrease these harmful effects to minimum levels. It will pave the way of producing hydrocarbons in more clean and efficient way. For instance, offshore platforms are mainly including several units that consume consumes energy from drilling facilities to accommodations. So minimum electrical power consumption of a standard offshore platform can be considered as 10 megawatt. And most of the platforms have an ability to generate its own electrical power by using gas turbines that includes pumps and compressors, which generates around 80% of all CO2 and NOx production of an offshore platform. So in terms of environmental issues, these are very crucial, and lowering these ones are crucial to make oil and gas industry more clean, actually. Okay, so this also makes the producing the electricity in acceptable range a vital environmental issue. There was a work, Corpus et al. Regarding on this. They applied a simulation model to present the possibility of green energy usage by using wind farms that are operating in parallel with the gas turbines, and quantified with the fuel saving as well as the reduction of emissions for an offshore platform in North Sea. As the result, the usage of wind power also resulted in 5% increase on efficiency of gas turbines, actually. So using a hybrid system will be cleaner and will be much more beneficiary in terms of efficiencies. All right. So in terms of wind power, so there are some formulas, basic formulas I would like to give in here. This is from the He et al. Work. They analyzed the technical feasibility of using wind farms in 3 different power capacities. These are 20, 100, and 1000 megawatts as a supplementary power source. The simulation results of real load data showed that it's possible to have around 40% annual reduction of CO2 and NOx emissions, actually. So the formulas that they used given in here. The swept area also formula has been given, the power density formula has been given, and the P rated, which is the function of this swept area of the rotor, the power density of the wind, and the efficiency is given as well. So let me pass this one quickly. Actually, there becomes always debate among scientists about both the beneficial side and available cost of renewables. By taking this into account, the fact that sustainability is determined as a tool met the demands of the society by not damaging future generations, wind energy can be considered as a sustainable resource directly. The sustainability of wind energy is also supported by its fuel-free content. On the other hand, what we can say, some academics state that the concerns related to the environmental and economic aspects of wind energy must be accepted. The idea of the incorporation of environmental worries of society with the tendency of the investors for increasing the shareholder value is considered to become more sustainable. Hence, the term dual sustainability has been introduced in order to attain simultaneous environmental and economic sustainability. Okay, so wind energy. About wind energy, the things that I will say is finalized. So another one, slowly, I'm passing to geothermal energy. So beginning from 1990s, the usage of geothermal resources in electricity production showed that significant increase worldwide. So it's based on transportation of water that absorbed the heat from the contacted hot rock through to the surface and converting the heat energy of the water into the electricity by using turbines. This is the mechanism. So also, it's known as there are thousands of oil and gas wells drilled and abandoned due to the several reasons. Production of geothermal resources by using these abandoned wells in oil field is another area of interest due to the energy saving, and it disables the problems such as high drilling costs, around 50% of total cost in a geothermal project actually, and geothermal fluid corrosion and scaling phenomena. Okay, it also creates alternative source which enables to use renewable energy during the oil production of the neighbor fields or in the same field. Okay, So the electricity generation by using geothermal power has many advantages, especially compared with the conventional sources. First, geothermal power is extracted by using the heat source of underground waters and no harmful environmental damage and no emissions that fossil fuels extracted while burning, right? So it means that the greenhouse gases generation has a significant reduction by using geothermal sources in heating. Okay, that's what we can say. So let me go through to this method. As you can see here, this is the well board. Okay. Actually, although there are some other techniques like using different subsystems which combined with the oil production processes, the easiest way of converting an abandoned oil and gas well into a geothermal well is to use a seal in the bottom part of the well and enable insulation by using the correct material. Okay. So a circulating fluid in a closed stem is injected to the well from the annulus part to get the heat of the rock gradually. And herein the mechanism works like an exchanger, actually heat exchanger. We can talk. Okay, changing heat exchange from the formation through to the liquid directly. Okay, and you heat your liquid and get your liquid through to the upper part. Okay. It enables a heat transfer without a mass transfer. So in other words, we can say that the circulating gets the heat energy by using the well walls instead of having a direct contact with the rock. So when the fluid is reached to the bottom part, the fluid heated enough, and the reverse flow starts in upward direction from the insulated inner part. So insulation prevents the heat transfer from the inner to outer pipe, and circulating fluid flows through the surface without losing any heat. Herein, it's crucial to describe the fluid flow rate as lower than the conventional geothermal systems to increase the efficiency of the heat transfer between the rocks and the walls also, and the circulation fluid also. Okay, so these are the basic formulas that has been used in a converted geothermal well. All right. For the injection and the extraction equations, actually, these equation numbers has been given wrong. It's my another work, because of that I get it directly. Okay, so let me pass through to the hydropower, another one. The use of hydropower is dating back a long history, actually. People use the force of a flowing water and rivers to produce the mechanical energy. Hydropower is one of the oldest energy sources used for electricity generation. Hydropower has the largest capacity among the renewables in the United States in 2019, actually. So the evaporation precipitation cycle of water is the main supply for water recharging of rivers, lakes, and oceans. The availability of hydropower is mostly affected by seasonal variation, of course, in precipitation. So the hydropower plants are usually constructed near water sources. The flow rate of moving water and the elevation between the water source and the turbine are the two important parameters determining the amount of energy produced and the efficiency as well. So water usually flows through a pipe and turning turbine blade connected through to the rotor to a generator for producing electricity, as we already know this one. In a hydropower plants, the structure of a hydropower plant. So conventional hydropower includes run-of-the-river system or storage system, which is supplied by the streams and the rivers. There's also another which we call pumped storage hydropower. In this system, for example, water pumped from the source to a storage reservoir at a higher elevation, and the water is stored in a higher elevation, and when you need it, you release your water to the lower direction, in the lower direction, and use and passes it to a hydro turbine, and electricity created. And if you need, you can use your water as well. So that's what we can say in terms of the working methodology of that. So the gross installed hydropower capacity, as you can see in the picture, from the color change, you can see the amounts. but the world's installed hydropower capacity was reached to 1,308 gigawatts in 2019 by adding 15.6 gigawatt from 50 different countries compared with the last year, with the previous year actually, 2008. So India became the 5th largest hydropower producer with over 50 gigawatt installed capacity, overtaking Japan in 2019. So you can see the top 5 countries in the figure. So China again, the first one, Brazil, United States, Canada, and India follows them. Okay. Another one, the highest growth in hydropower capacity. The highest growth compared with the previous year is Brazil, China, Laos, interestingly, Bhutan, Tajikistan, and Russia get the first 5 place. So according to the regulations or governmental regulations, of course, has a very important factor, plays a very crucial role shaping this figure actually. Okay, another one related to this one actually, the hydropower, Seaway power. This is another green energy source that has a great potential, which converts the sea wave energy to electricity. Several researchers also studied about this wave energy resource assessment of regions and countries such as United States, Canada, Australia, Europe also. This is proven, and they have these methods, sea wave power usage methods, a significant energy source which needs to be considered actually. So, for instance, ENI is planning to use wave energy devices to power oil and gas operations in Adriatic Sea now. Okay. So, ocean sides are also places where most of the offshore platforms based. Therefore, the development of technologies for energy conversion from sea waves will definitely pave the way of using this method as a power source in offshore platforms in North Sea, especially, needs to be considered. Okay. Now, the estimation of worldwide coastal sea wave energy resources is around 2 terawatt. Gannon Williams' shows that. Unlike the fossil fuels, the biggest advantage of sea wave energy is its continuation. In other words, waves always continue to crash upon the coastal regions and shores. Also, it is abundant and available in worldwide. It's an advantage. Secondly, the environmental effects are limited and do not have any chemical waste or pollution effects. Also, do not have any harmful effect on land. This is also an advantage. However, it includes some environmental concerns as it creates a risk of fishes and marine mammals to be struck by turbine blades, especially in high tide, low tide times. So the operational marine energy devices also emit underwater noise, which has a negative impact of sea creatures. Additionally, it can affect the sediment transport as well as the water quality in the long-term period. That's what we can say. The last one I wanted to talk about, this is also a part of a very big discussion. Is this a renewable energy source or not? People are still discussing this one. I will try to examine with the reasons why it is renewable, some part of them. So nuclear energy is one of the most efficient and effective renewables in terms of generating the electricity. There are currently 440 nuclear power plants operating across the world. One of the main advantages of these nuclear power over other energy resources is its less release of radiation and being the environmentally friendly. So the influence of COVID-19 was not so considerable actually in the nuclear power industry in terms of operation of reactors for generating electricity. In the first quarter of 2020, nuclear energy generation decreased by roughly 3% in comparison with the first quarter of 2019, which was the contribution of global reduction in electricity demand. According to the statistics, this nuclear power reduced by 2.5%. And the main reason behind this decline, which were formed due to the spread of the pandemic, of course, were delaying of both maintenance and construction of some projects and less demand to the electricity. The weakening of the spreading trend of COVID-19 can increase the overall demand for the electricity obtained by nuclear power. So the decrease of the demand on nuclear power became also terminating of the operation of several nuclear facilities. After the Q1 of 2019, 6 new nuclear reactors within the total capacity of 5.5 gigawatt have been introduced for the processing. However, there became the shutdown of several nuclear facilities during that period, which had the ability to generate the electricity of the twice time more than the operating reactors, according to the International Energy Agency. So, in conventional way, the fission is the event of a nucleus with a very large atomic number breaking into two different nuclei with smaller mass numbers, okay? The conventional working mechanism of a nuclear structure, okay? So, the radioactive elements are used and the fission reaction requires the first energy that we call activation energy, right? As a result of these reactions, unstable nuclei and the neutrons are formed and each of these neutrons react with the uranium atoms, okay? So, if fission reaction are not carried out in a controlled manner, the energy released creates a big explosion and can be very harmful for the environment for worldwide, okay? So the best example of uncontrolled fission explosions are atomic bombs, for example, okay? So when we look from this view, so it is not environmental energy source actually, okay? But in last years, there is another technology has been developed. We call it fusion. Fusion is the reaction of atomic particles, okay? Here two light elements combine as a result of nuclear reactions to form a heavier element, totally different from the other one. So this is also known as the nucleus reaction, and it causes a huge amount of energy to be released. The heaviest element that can be formed by this process is iron. This energy potential was first used in the production of the thermonuclear weapons, which are described as hydrogen bombs after the World War II. To give another examples, we can say that the fusion reactions in the sun take place simultaneously at all times. The light coming from the sun to our world emerges when the hydrogen nuclei combine to turn into the helium, and the energy is produced as a result of mass loss during this transition. At this point, of course, we can use the famous E equals to mc square equation to calculate this magnitude of energy, right? So utilizing fusion as an energy source is a very difficult task that must be carried out under high supervision, of course. Atomic nuclei can positive charge, and then they want to be brought closer to each other. They repel each other with a great force. This fusion of positively charged nuclei is only possible by applying a force that can be overcome the repulsive force between them. So the required kinetic energy of equivalent to the temperature of 20 to 30 million degrees. As a result of these, the reactions using hydrogen energy, no radioactive material is produced, and it is a 100% environmentally friendly method because there is no radioactive material, direct hydrogen, okay? However, when it's used to generate electricity and heat, it's of great importance to act a highly dependent manner on each procedure. Both types of energy are much cleaner than fossil fuels and are less harmful to the environment when their systems function correctly. And generally, the efficiency levels of renewable energy sources are very low, and it's predicted that it will reach the desired levels in time with the developing technologies, of course. The energy production in nuclear energy results in extremely high power outputs. So in short, that's what I can say. All the measures are taken based on the artificial intelligence and the worldwide application of high safety fusion reactors that have reduced the human-induced error factor to zero, will meet all the energy need of mankind with zero damage to the environment and without the need of any other fuel type, including the fossil fuels and renewable energy sources, will make it possible. So the most logical solution that can be made until reaching the peak level of the fusion technology is that each country provides the most efficient combination that will give the least damage to nature by making an optimization between these energy types. So after this part, I am totally sure that this will be definitely adapted to oil and gas industry also. It will be used as a part as well, but it will be definitely adapted to oil and gas industry. That's what I am expecting. So this is the end of day 2. Thank you very much for listening. If you have any questions, I will be glad to answer your questions directly.
I don't have any questions.
Thank you so much.
Thank you for presentation.
Thank you very much. Thanks from my side.
Thank you very much, Mr. Hakan Canbaz, for your contributions in these 2 days and these informative presentations. There are 3 people who raised hands. Mr. Reyes, you can open your voice and give your question.
Yes, please.
Yeah, hello, I'm Riyaz. Okay, on your slide 81, though it is cleared by the next slide, I will still request to remove this this line saying that it's less release of radiation and being the environmental friendly, considering the catastrophic effect if there is an accidental release.
What is the slide number? Can you say again?
Slide number 81.
Slide number 81. Okay.
In the last line, you're mentioning is less release of radiation and being the environment friendly this nuclear energy.
Yes.
I believe this this agreement, this sentence is not correct, considering the catastrophic damage it can cause from an accidental release.
Okay.
So,
now, actually, in this part, we can maybe correct this one as the fusion energy. Okay. The latest one, which the technology is currently in development phase, but reached a very good levels. Fusion energy is totally includes no radiation. Okay, just uses heating the hydrogen. All right, it heats the hydrogen in atomic level. It combines this two small nuclei to create a bigger nuclei. All right, so mainly. So there is no radiation in this one. If you use a hydrogen, okay, there is no radiation, and totally environmentally friendly. All right, totally environmentally friendly.
So maybe
but when we talk about the oldest method, the fission, of course, need to be monitored very well. So if we couldn't do that, so it can be very harmful. I am agree with that totally. It can be very harmful, like has been faced in Chernobyl, in Fukushima, right? So there can be harmful effects, of course. But here, I am talking about the latest technology one, the fusion energy. Okay.
Okay. So maybe some rewording will help. Okay. And the second one, please go to slide 76. I was a bit confused with the description you provided there and the words on the slide. So do you mind to repeat this geothermal, how this works, how is the flow? Because
Okay,
it's being said that the bottom part of the well is sealed, then how the flow takes place?
Exactly. Now, these wells mainly there are some projects which has been successfully implemented this technology, by the way. Okay, one of them I remember in Croatia. There's a project. So there are oil wells. Okay, there are oil wells. The field has gone to a depletion, and then production stopped. Okay, not feasible, and they left these oil and gas wells. Okay, people left, the oil companies left this one. So you take these oil wells, okay, and insulate the lower part of that. Okay, insulate the lower part of that, the lowest part. You don't need any connection with any reservoir or whatever. You just insulate it, just the working mechanism of a heat exchanger. Okay, you put a liquid inside, chemical liquid, whatever, inside. You are in a isolation, direct isolation. You put the liquid inside. What you have a pressure and temperature gradient, right, with the depth. So when you reach, for example, the 2,000 meter depth, okay, you can have 150 centigrade temperature in the formation, the hydrostatic. Okay, so what happens? You put you release your fluid through the inside of this one, and you reach to the lowest part of your valve, and there is a conduction between rock, your valve, the materials of your valve, and this fluid. Okay, so you have to select your rate, the speed of fluid, of course, in a certain level. Optimization needed according to the each valve has to be different. Okay, so you have to optimize it very well. So after that, with the conduction, heat conduction between your rock, your valve, and your fluid, you transfer the heat of your rock through to your fluid. Okay, so your fluid heated. Your fluid heated, and you got this heated fluid from the inner part through to the up. It comes from the annulus part through to the lowest part, heated, and then you get it from the center, from the tubing through to upper part. But here the concern is your tubing has to be isolated directly. Insulation needed. Okay, because I don't want to release any heat through to the annulus part, right? So your tubing has to be insulation, needs an insulation. So why? Because I have to keep my heat through to the surface. Okay, so from the center you start to produce your chemical fluid through to the surface with this nearly same heat, same temperature level. Okay, maybe 1 degree, 2 degrees lower, but nearly same temperature. And then you get it to your facility. You transfer your heat to another fluid in the surface, transfer it to another fluid, okay, and use that heat as conventional geothermal for the electricity usage, electricity generation, and then same fluid that you used in your well sent back as a closed system, okay?
Recycling.
Sent back to your well, definitely, and recycle.
So correct me if I am wrong. So the fluid is passing through the annulus, and the bottom part is sealed, and there is a gap between the tubular part and the bottom, right? So the fluid is coming through the annulus and then passing through this
exactly. There's the empty place has to be, because your fluid has to pass, right? So
here was the confusion. Okay, thank you. Yeah,
with a kind of bridge plug, you can use a bridge plug in here, okay, to make an isolation, direct isolation in the bottom of your well, okay, and your tubing will be, for example, 5 meters above your well, all right, and your fluid comes to the chamber, end of the chamber, it heated, and then from the tubing it produces insulated tubing. Not a normal tubing that you are using in an oil and gas operation or a geothermal well operation. Insulated tubing needed. I don't want any heat transfer through the annulus.
Yeah.
Okay?
Right. Thank you very much. Yeah.
You're welcome. There are some projects. If you're interested, send me a mail from my, I will give you my mail address. Send me a mail. I will send you the details about the projects about. No worries.
That was very nice. Thank you.
No worries. No worries. Another question, please.
Mr. Mehdi Bashirli, you are welcome to ask your question.
Hello. First of all, I want to thank to you for these valuable and informative knowledge presentations and organizers. I have a little question from the beginning of today's presentation. At the beginning, you said that there are several researches about renewable energy, but from the internet connection problem, I didn't catch it. This research shows that what? Why we need that researches?
Actually, I tried to give as much as I can do. The research has been done to implement renewables to oil and gas industry. The main reason of this one, actually, why they are focusing this one, because the global warming issue now reached to a certain level, actually, that this population, with this population, the Earth could not actually cope with this one anymore. Okay, so we have to lower as much as we can do. Of course, we cannot leave usage of oil and gas. It's impossible, because the most effective and most efficient way of fuel resource, right? And using another things, plastics, whatever,
Yes,
right?
yes.
So it's impossible to leave this one. But now we can think. People start to think how we can lower our carbon footprint. Okay, I am producing this one, even I am producing this one. So how can I lower, for example, in an offshore well, in an offshore location, you are using natural gas, even to generate electricity by using these. If you want to use these equipments, all these tools, even your crew locations, whatever, in every place we are using natural gas, right, to assist, right? So
Yeah.
how I can adapt this one to renewable? So this is the main concern, actually, that we are starting. Also, I am working in some part of these projects in some places. So this is actually the starting point, because we have to make it more environmental. Every step that we are doing, of course, this is harmful. I'm accepting that, but how we can make it more one step more environmental? That's actually my point of view, and we have to combine this one, actually, before being too late. That's what I believe. These hybrid systems, if we can do it as much as lower, we can stop this using these fossil fuels, but it's impossible. So this is actually this aim of this all research. The aim is how I can lower my carbon footprint, how I can leave a less carbon footprint to Earth to lower this global warming effect. That's the reason.
Okay, thank you so much. I got it.
You're welcome. You're welcome.
Mr. Ümid Abdurrahimov.
Hello, can you hear me?
Yes.
Yes, sir.
Yeah, I'm Ümid Abdurrahimov, and I'm a fresh graduate of Baccalaureate School. First of all, I want to thank you for your great presentation. Actually, I had one question, but before asking my question, I want to mention one thing about previous guy's question about geothermal energy. You know, last year I have last year I've participated in a scientific conference about the same topic, the geothermal resources in Azerbaijan. And for example, in Azerbaijan, the temperatures of geothermal sources are so low, like maximum up to 100 degrees Celsius. And as far as I remember from that, in that case, we couldn't circulate the liquid as you mentioned, due to the heat losses. And in that case, we from economical calculation, I saw that another method was circulating the steam, the circulating liquid was direct circulation, and there was another method called steam steam circulation. In that case, we do very much the same thing, but like indirectly with steam, we circulate it, and it takes temperature from the well. Then by that we take the heat. So before asking my question, I want to just ask, maybe you want to add something about this steam, and then I can ask my question if you want, or can I say right now?
If you get better results in steam, okay, this is just related to the conduction mechanism of your steam, okay, from one molecule to another. The heat conduction capacity is very important. So why? Because I am sending it to a certain speed, right? I describe my speed and optimize my speed, and at that certain speed, I have to get your speed has to be in the maximum level of the conduction of heat capacity, okay? So this is just related to this one actually. So you have to select the best fluid, best liquid or fluid, we can say, to conduct your heat from one molecule to another molecule. Okay, from your well to from your well structure to your liquid or fluid. Okay, from rock actually what affects not only this one, the material that you use in your well, the cement that you use in your well even affect this one, because another materials, different materials affect in different the conduction mechanism of different materials are different as well, right? So from your rock to your well and your well to your fluid, this is the mechanism. So from your rock to your well, okay, the structure of your well, the material that you use in your well, the cement material, the tube, not tubing, we can say the casings, okay, the materials, the casings, the conduction capacity of your casing is important. So all these ones has to be calculated separately, one by one, okay, until reaching to your fluid. So you have some more barriers as well, okay. Of course, your fluid is important, but some more barriers as well. I am not capable about currently. I'm not capable about what type of materials has been used in Azerbaijan, for example. But
actually, in Azerbaijan, we don't use it. Just it was like the probability of using it. We don't use it right now.
Okay, but that's what I would like to say actually. Apart from your fluid, you have to, first of all, you have to examine what type of materials you used in your well sketch, has been used in the well sketch. According to that, the material that you used, the fluid that you used also can change.
Yeah.
Okay. The heat capacity, because conduction capacity is very important. The dominant mechanism in this part, dominant mechanism is not the convection, the conduction. One molecule to another, one molecule to another. Okay, so there's an optimization definitely needed for each case, different, by the way, for each well different. From one well to another, you will get different results, definitely. That's what I can say.
Yeah, thank you, perfectly clear. And now my question about nuclear energy.
Please.
So actually, I've attended some seminars about nuclear energy, and like as you mentioned, it has huge advantages like high energy with low pollution, and as I know, it's the only the like energy sources that its pollution can be contained. So you know, looking at the all these advantages, like one thing I don't understand, that why nowadays its application, like discussions about its applications, are not as popular as other renewables. Like personally, I don't see many places in which like this topic is discussed. Like solar panels and wind power, these are very popular, but nuclear energy is not. So do you think that like it is that's the true way, and we don't need to take that into account, like in global scale, like seriously, because like other sources, like other sources can support the future energy without it? Do you think that? Do you think that other sources, other renewables can support future's energy demand without nuclear energy? Because as you know, nuclear energy produce very, very much energy with low pollution and other things, but the other renewables are not that effective. So how do you think about it?
Okay, so first of all, we have to separate the nuclear energy into two different parts. Okay, as I mentioned, the first one,
Yes,
conventional methods. Okay, like we examined in Chernobyl, the conventional method. If you have an error, if you have an operational failure, then your results will be catastrophic. Okay, your results will be catastrophic. So because of that, people in each region, in each country, people stays in a distance to this type of technology. Okay, so governmental issues happens, and governments want to, if they want to establish a power plant, nuclear power plant, they can do this. Okay, but from the public side, people, as much as all people, I have the same thing as well. Okay, so you have to stay in a kind of distance to this conventional one. But the second one, the fusion energy that you can see, this is a fusion reactor, as you can see in the picture. Okay, so this one just uses the hydrogen. Okay, and heats the atoms of hydrogen directly, heating, and then by using this heat, the hydrogen itself creates extra heat, and the efficiency of this one in incredible levels. Okay, the incredible levels. This is very clean source, but now the technology is in still development phase. There are some applications in France, in China, in US, in Korea, North Korea. There are some applications of this method. They reach to the levels of the sun heat. All right, to the levels of sun's heat. They are successfully doing this one now, and the harmfulness when we compare it with the first method, the conventional method, is nothing, cannot be compared. And another thing, this is much more efficient compared with the oil and gas as well. Okay, much more efficient. If the technology can be implemented successfully, this will be used in each stage, in each levels. Okay, it can reach to incredible levels that we cannot imagine it. Okay, so we have to talk the nuclear energy in two different sides. If we are talking about the conventional side, I am agree with you. We cannot say that this is environmental because if you make a operational failure, then catastrophic results you can get. But this one is totally different. Okay, so the technology is developing. The future will show how it will go. Okay, but from my side, this is the only technology that can take the place of oil and gas. Only one, not any of the renewables, because renewables can be a complementary energy source. Can be a complementary, and it can complete the part of the oil and gas with the hybrid structures, because the efficiencies I talk in here, the solar energy efficiency is around 20%. But we are talking about a resource, oil and gas, with the efficiency of 98%. How we can compare these two? Impossible. Okay?
No.
With current technology. So only the one, if the technology is developed, this fusion energy can be a kind of alternative way. But all other resources are the complementary way of using energy for oil and gas. Okay? That's what I can say.
Yeah. Yes. Thank you very much. And one last thing, can I take your email? Maybe sure. You can mention in this chat, or maybe our organizers can mention.
I will send it directly. No worries. I have all your mails. I will send directly. No worries.
Also, we can share. No worries.
Yeah. Also,
Please.
Diana can share. Okay, very good, very good.
So first of all, Mr. Claudio Marcelo Fonseca, you can ask your question.
Yes, thank you. Thank you, Halal, for your time. It was a very wonderful
Thank you.
workshop, today workshop.
Thanks for
I have just one question. What do you think regarding this renewable technology? Which one is going to be the most dominant and sustainable technology for our industry? And the other question, I'm sorry, I have another one. Is there any published matrix where you have the pros and cons on all these technologies to see which ones are more adaptable also for our oil and gas industry?
Actually, in current status, sir, it seems that the solar power is much more feasible and can be adapted to oil fields directly. And wind power, it comes in the second one. That's why, because I gave this order actually, start with solar and wind. Solar one is has a huge potential to adapt to oil and gas fields, first of all. Okay. And the wind in the second one, especially in offshore sites, wind has a huge potential to assist the electricity. But solar, in yesterday also, as I mentioned, in EOR projects for heating issues, solar can be adapted to this one as well, apart from the electricity generation. So solar seems the first one that can be adapted to oil and gas fields. In terms of oil and gas fields, I'm talking. When we come to the usage part, public usage part, now there are some projects called smart cities, okay, and these projects are directly aiming to use the renewable energies and the hydrogen energy, producing hydrogen by using renewable energies, and in places that renewable energy is not enough, assisting with that with natural gas. But the main concern is using hydrogen energy, hydrogen fuel cells, actually. Okay, so the technology is going to implement solar and wind in first case to produce hydrogen cells as well, in smart cities. So that's what I can say. The solar and wind will take the lead in close future, and then if they succeed with these ones, and then they will start to develop the other ones. For example, in places of the establishment of these smart cities, if there is a close source of geothermal energy, they will implement that one, for example, okay, according to the situation. So, but the first ones that I can say, wind and the solar and wind actually, will take the lead directly. We will see up to 2030, these two will take the lead. That's what I can say.
Okay, thank you. And what about the matrix? Have you seen the matrix with pros and cons of each technology and the adaptability? Because you know, one thing that I'm, let's say, a little bit concerned is about the disposal of all these solar panels, all these turbines, and all of that stuff, because they have
that's a very good question actually. In terms of the literature review, I did not face anything like this. I am producing also some papers related to these topics, and I'm making my literature review. Till now, I did not see anything like this, but it's a good opportunity. I can create one of them actually. So
okay.
It can be one of the things that I can concentrate. I can create one of them because I have enough actual literature review regarding on this. Why not? I can concentrate on this one actually. That's what I can say. If I do one, I will definitely share.
Just let me know if you need some help.
Definitely, sir. Definitely.
Thank you very much.
Thank you very much.
Thank you for your question. And dear attenders, if you have any question, you are free to ask. Don't hesitate. You can open your voice directly. I think it's less chance to ask any question in this seminar. So I see there is not any question. So Mr. Hakan Canbaz, thank you again for this informative session. I think everyone learned something today.
Thanks from my side. I am also thankful to all of you to join to this 2 days course. Thank you very much. See you in the next one, inshallah.
Thank you, Mr. Hakan, for
Thank you so much.
enlightening speech and great presentation.
Thank you.
And we are really grateful for the time and effort that you took to share your experience and thought with us and answer all of the questions of participants by the name of Society of Petroleum Engineers Khazar University team.